Friction Part 1. Friction is a force that holds back the movement of a moving object, means it opposes motion or tendency of motion. Friction is caused by the microscopic interactions between the two surfaces. Let us analyze the situation. Here, block is placed on a rough surface. When a block of mass m is placed on a rough surface, the irregularities of block and rough surface come into contact. These irregularities are not visible from naked eye. Let us enlarge a small portion with the help of a microscope. Then we will be able to get a better picture. The surfaces of ground and block have lots of irregularities, therefore, they are not in contact at just one point. Actually, they have contact at several points, as you can see here. It means that whenever a body is in contact with ground, then they are in contact with the ground at different points. It means that they will experience different contact force at different point. Now, all the contact forces combined and oppose the motion and tendency of motion of body because of the interlocking of irregularities. Interlocks oppose the relative motion between surfaces. Due to the interlocks, contact forces are distributed in various directions over the surface. Here two surfaces, that is ground and the block, are in contact. Look at the contact forces like N1 and N2. It shows that contact forces are in different directions. We can resolve contact forces in two components, that is horizontal and vertical components. The vertical components add up and balance the weight of the body. Summation of horizontal components is defined as friction. Thus, friction is cumulative effect of horizontal components of all contact forces exist between the surfaces. When a body is placed on ground, then friction will not act as all the horizontal components cancel each other. If an external force is applied to the body, then frictional force opposes the tendency of the motion or motion, whereas normal reaction always exists in perpendicular direction. So, we can say that ground applies two forces on the body. They are normal force and friction force. Both are contact forces. Therefore, we can say that normal reaction is vertical component of the contact force and the friction is the horizontal component of the contact force. There are in general three different types of friction. Let us see about them: static friction, limiting friction, and kinetic friction. Consider a block of wood lying on a plain horizontal table. There is no force of friction as the block of wood is stationary. Push the block lightly with the hand. The block does not move because the force applied by the hand is exactly balanced by the force of friction acting horizontally in the opposite direction. Now, push the block a little harder. Still, the block does not move as the force of friction increases so as to become equal and opposite to the applied force. Thus, the force of friction has a remarkable property of adjusting its magnitude so as to become exactly equal to the applied force tending to produce motion. However, after a certain limit, the force of friction cannot increase further. If the applied force exceeds this particular limit, then the block starts moving as the two forces, that is, the force of friction and the applied force, are not balanced. The maximum value of the force of friction, which comes into play when a body just begins to move over the surface of another body, is known as the limiting friction. When there is no relative motion between the two surfaces in contact, then the friction is a static friction. Friction is capable of adjusting itself not only with regard to its magnitude, but also the direction of the applied force. The force required to keep the body in steady motion after the motion has once started is called the kinetic friction. Magnitude of limiting friction. It depends upon two factors. First, normal reaction between surfaces, and second, nature of roughness. Limiting friction is directly proportional to the normal reaction between the surfaces. Fl is equal to mu Sn, where mu s is coefficient of static friction. It depends upon roughness of surfaces. Let us understand it with the help of a practical illustration. Let us place a block of mass 5 kg and coefficient of static friction between the surfaces is 0.3. Normal reaction is mg. Here it is 5 into 10, that is 50 Newton. Limiting friction is equal to mu s into n. It is equal to 0.3 into 50, that is 15 Newton. If we apply horizontal force F on the block, then static friction appears. It does not allow the block to move up to a certain limit. If external force is 5 Newton and it is less than limiting friction, then value of static friction is also equal to 5 Newton and body will be at rest. Now, if we increase external force to 12 Newton, again it is less than limiting friction. This time static friction becomes 12 Newton to counter the applied force. Block remains at rest. Body will not move even if the external force is 14.9 Newton. If we increase the external force to 15 Newton, then static friction won't be able to balance the external force. At F equals to 15 Newton, the interlock between body and ground surfaces breaks and body starts sliding. At this instant, static friction does not exist as body start moving and kinetic friction comes into action. Magnitude of kinetic friction. Magnitude of kinetic friction depends on normal reaction acting on the body. It means that Fk is directly proportional to n. So, Fk is equal to mu k into n. Here, mu k is coefficient of kinetic friction. It is very important to know that when body starts moving, interlocks between the surfaces decreases. As interaction between the surfaces is more established when the surfaces are at rest. Therefore, kinetic friction is less than the limiting friction. Coefficient of the kinetic friction is less than the coefficient of static friction.